All right, so this test starts off with the confidence interval stuff. So it's those 5 formulas. 3 of them are confidence interval formulas. The other 2 are the N formula. So you've got those bad boys. Remember, the first 2 together constitute a legal note because they're formulas. What can I do? When do you use z-scores? When you know the population standard deviation. When do you have to use t-scores? When you only know s. Now, of course, both of them require what to be true? Yeah, that could be one way to get it, but what do they require more directly? They require that you are working with a normal distribution. I like it. Either they'll say it, or n is greater than 30, right? Now, what do you have to check for this one to make sure that it's normal? What do you check for NPQ problems? Yeah, what's greater than 5? NP and NQ. They both have to be bigger than 5. So in the homework, a lot of people are telling me in the 8.2 that n is greater than 30. I don't care. NP and NQ have to be greater than 5 each. I like it. Okay. Don't write that on your formula sheet. That sucks. It's not a formula. It's an idea.
Aww.
Okay, I like it. Yeah, it's a formula. It's got numbers. No, it's an inequality. It's not an inequality sheet. It's a formula sheet. Let's see. Then you got your n stuff. Now, if you want to, it's not really a different formula, but I did put this on the quiz just because I had a question related to it. Whenever you don't know sigma, you use t, right? It's not really a different formula, but if you want to put it down here, t squared s squared over e squared, what to do? And think about this. This really makes a lot of sense. If you don't know what the population standard deviation is, should you have to take a larger or smaller sample? If you're not sure what the population standard deviation, you only know the sample standard deviation, should you have to take a larger or a smaller sample? To keep your error below something, you have to take a larger one. And aren't the t-scores bigger than the z-scores? So that will make the n bigger. Why did I put a square on you? Get out of here. Sorry. I was going crazy with my squares. This is n equals that stuff. I like it. And then the other one for p hat, q hat stuff. Z squared p hat q hat over e squared. You can't write this down up there, but if you don't know what p hat and q hat are, you use, if you don't know what p hat and q hat are, you use 0.5. That's your best guess, 50-50. Mathematically, it makes n the biggest, which kind of goes along with this idea. When there's something you're not sure about, you should have to take a bigger sample to make up for that. All right. So that's all stuff from the confidence interval. I think it's chapter 8, right? And then you get into hypothesis tests. And if you want to, you should have this on an earlier sheet, but you got this here. And you got this here. It's all old news, right? So that first type of test we did is old news. We had the z-star was the same z-score formula we used before for groups of things, right? So you have to change your standard deviation. Is that cool? Okay, maybe. Now, if you want to, and by the way, this does not say sigma divided by x. This says sigma sub x bar. We use subscripts as almost like an adjective. This is the sample mean standard deviation. That's the standard deviation of all the sample means. So that's a descriptor for it. It's not a little formula, sigma divided by x. No. Okay. If you want to, and I think most of you probably won't to, although I kind of wish you wouldn't have to. You could put this down for yourself. It's the same stupid formula. It's just got an s in it. Right? So then s x bar is s divided by square root of n. So I'll let you do that. It'll remind you that just because it's s doesn't mean you don't have to divide by the square root of n. You still have to. That is for individuals. That makes it into the standard deviation of groups of size n. You have to do that step. Okay, like it. And then we got the brand new one. The new formula, Z star for p hat stuff. My data minus the population percentage. Notice the only hatted one in here is the first little dude. These are the non-hatted ones, which I think would be a really good band name. And then you wear hats just to throw people off. I don't know.
How do you collect p hat again?
Yeah, what the hell is p hat?
U over n.
X over n. So it comes from the sample. I like it. P hat is your percentage that you see from your sample. P is the population percentage, which we're assuming is the one that shows up in the claim. We're assuming that one, that the HO is real, that it is that. I like it. So it's always my data minus whatever the middle is assumed or known to be divided by the spread. It's always that. The Z-score formula does not change. It's okay if you don't believe me, it's fine. And then I think finally the last thing, if I remember everything correctly, is that giant freaking Z-star formula, right? For when we have two samples. I don't think I said this last time, or did I? So we didn't do 10. 10.3 wasn't a part of what we were supposed to do. I don't think I left it off. That's right. So that's fine. So 10.1 and 10.2, totally doable. Aw. So if you want to just keep going over there, I just ran out of room. Z star equals x bar 1 minus x bar 2 over square root. And it's either going to be sigma 1 squared over n plus sigma 2 squared over n 2. And then you can make, again, it's really the same idea as over there. The only difference with this one is going to be I don't know freaking sigmas. I only know freaking s's. So these are the same formulas as these, just with everything doubled. All right, I like it. Some of you guys have a bemused look on your face. That's better than miserable look on your face. Yeah?
In the parentheses, I know what S sub x bar is, but what's just S?
Yeah, well, what's just S? What's S? Sample standard deviation. S sub x bar is the standard deviation of all the sample means. Yes, cool. So S is the sample standard, meaning individuals. How spread out are the individuals in your sample? S sub x bar is how spread out are all the possible samples of that size from each other. That's why you still have to do this. If people go, it's already a sample standard. No, it's one for individuals. You need the one that works for groups. That's why you still do this. That's why you still adjust it. I like it. Anything I left off? Anybody? Anything I left off? Okay, cool. Anybody else still need a copy of the practice test? Michael, you need a copy of the T-score stuff? Yeah, sure. Sorry, I kept forgetting to go back to your email.
Anybody else need a?
Practice test. No, okay. I'll take that. All right, guys. So let's see. Has everybody got those? Looks like it. All right. As always, I desperately request that you go actually compare what you've written with what's in the book. Make sure that you didn't see my crazy writing incorrectly. Okay. So what I want to do, unless there's any specific questions right now, I kind of would like to have you guys do number 6. Main reason is I didn't put it on the answer key. Main reason for that is it's a new question, and I had my answer key already made from last semester, so I just didn't put it on. So I'll tell you this. I'll give you, well, not yet. This is the one. Which formula is number 6 going to use eventually? This is a hypothesis test. Going to use all 5 steps. Which formula is it going to use eventually? What's the idea behind number 6? Is it 1 sample or 2 samples? It's 2 samples, right? 2 samples, so you need the formula that's got room for 2 sample means and 2 sample standard deviations. And look at this little dude here. Yep, I like it. So your first step on that problem is throw all that information into list 1 and list 2 and figure out the sample mean and the sample standard deviation. So I gave you the data. I didn't tell you what the X bars and the S's were. You got to figure that out yourself. So if you get that done and you want to double check it with me, I can tell you if you got it right or not. And of course,